me questions, and then I hope all of you will come see me on a personal. Even those, I have seen a couple of you who did really well above 100% after the curve. I still see you, but the meeting is a little shorter. So I want to see every one of you, each one of you, just to see how you're doing and what issues you have, okay? So this, I'm just doing this tonight so I won't cancel class. But this does not replace the session I want with individuals, okay? So the first question is this. All the items below are moments of a distribution. I mean, I think this is simple. We at the beginning of this semester, we discussed how many moments? 4 moments, right? The mean, the variance, the skewness, and the kurtosis. So anything that is not among those 4 is the answer. Can anybody tell me what the answer is here?
Expected value.
It's B. B dictionary.
Yes, the expected value is the mean, remember? So this is the first moment. Expected value is the first moment. Variance is the second moment. Skewness is the third moment, and kurtosis is the fourth moment. So stationarity is not a moment. Okay, so this is the answer B. All right. So again, if you have a problem with this, just make a note of it. When I see you individually, we can talk more. Okay. All right. But I consider this to be one of the easier questions on the test. Number 2. This is many long sentences, but the answer is easy. This is one of the couple of questions I did with R. I didn't want you to do anything with R, but I wanted you to remember what you use for homework. We have been assigned the task to determine if the daily returns of AXA follows an ARIMA 212 process. This is just to carry out this task, we need to first download the last 20 years of data. So this question is really about downloading data. Which of the following R packages would you recommend as most suitable to download the required data? This comes directly from your homework. Yes, absolutely, it's QuantMod. This is directly from your homework, all right? Okay, this is, I mean, user R and T-series, Zoo, F-basics, you have used them, but user R you never heard of. This is a group, or a discussion group about about R. Okay. So the answer is D, QuantMod.
Professor, were all the exams formatted the same way, like the same questions, number 1, 2, 3?
What do you mean, like the final exam?
No. For our test, like for example, question one the same for everybody? All the items listed below are moments of a distribution, or like did some people have that one as question 1, and some people had like question 3 as question 1? Like the order the same?
Okay, I don't recall what I did, but usually we have many options as professors, okay? I have to go into Blackboard to check what I did. Sometimes in the past, I have made up exams where, not for this class though, where you are not allowed to go back. So you just answer question 1 and move on to question 2. If you do question 2, you cannot go back to do, if you move on to question 2, you cannot go on to do question 1. So we have many choices. I don't think I did that for you. You were able to go back on your exam, right?
Yeah, we were.
Okay, so there are many. I have to go back to Blackboard to see which buttons I checked.
Thank you.
Okay, but everybody had this exact 25 questions. In some other exams, I make like 3, 4, or 5 versions. William, that was you that asked me the question?
Yeah.
Okay. For some tests, I make like 5 different versions, so that if you maybe look in this class, maybe 3 or 4 of you will do one version, and even those versions will be totally scrambled in terms of questions and in terms of answers. Okay, so we have many choices, but because I trust you guys in this class, I don't go crazy. I didn't go crazy during this exam, I don't think. Okay.
Okay.
Okay. So the third question is, which of the following conditions must hold for a set of data to be regarded as coming from a normal distribution? Okay, so for a normal distribution, you just have to think for a second. What are the conditions? What are the things we discuss as the conditions for a normal distribution? Andrew just told me, somebody told me E. Yes, so E is the correct answer. Skewness must be 0 and excess kurtosis must be 0. Okay? All right, so that's number 3. Number 4, which of the following items are stylized facts about time series? Again, before I continue this, I brought this thing out. Hold on a second. Yeah, this is, I think I posted some articles about stylized facts at the beginning of the semester. And I suggested you read them. Many of you, actually all of you, if not all of you, read them, and you came back the next day, and then we discussed this. Okay, so this is the one I told you was really important, and I think I gave you. Yeah, we discussed stylized facts here, and there were 11. I remember vividly. It's in one of the tapes of the class. There were 11 of them. I ran through each of them quickly, and I told you that this class, we shall be focusing on some of them. So if you had this list, you would just have to check it against the list of the exam I gave you. All right. But on the question I gave you, one of them actually is really, yes, sir. Yeah, I mean, you have, it's in your class note, I assume. Okay. Yeah, I mean, you take class. I mean, when I record my classes, that's why we record it, right? So that if you are not in class, you can look at it later. But even if you are in class, when you study later, you can take notes, right? Which is even better than in class, because for in class at Baruch College, after that class is over, you don't have, when you study privately, you are not able to go back and check it. But on Zoom, for online classes like this that we record, when you study over the weekend, you can get the tape and then you can take more notes, okay? All right, that's why I like online more now. Yes, Dan? Yeah, but as a professor, I don't like online because I don't interact with my students the way I like. All right, so volatility clustering, heavy to diminishing continuous volume. So what do you think is the answer here? Huh? Yes, it's C, because C is not on the list. So A, I happen to know that A is on the, I know all of them, but if I put myself in your position, you have a list next to you, you've taken the notes, you will see that C is not on the list. C, there's something about value at risk there. Let me just show you. But it's not exactly C. Let me see, is that, I think there's something about value at risk there. Oh, not here. Okay, not on this list, okay? Conditional heavy tails have relate a little bit to value at risk. All right, but conditional value at risk is clearly not one of the one of these 11 that I discussed in class. Okay, let's go on. Number 5, I think everybody should have been able to get number 5 because you know it was one of those things we discussed in class. Which of the following measures of dependencies is most highly recommended for measuring the linear relationship between two variables that are continuous?
Pearson's rule.
It's Pearson, right? It's the usual one. Remember the day I introduced this in class, many of you said, Professor, we've never heard of all of this. I said, yes, but Pearson is the one you have been using all throughout your education at Baruch. I introduced that as Pearson because of this thing, continuous and linear relationship. So Pearson is one, okay? And when you have a non-linear relationship, Pearson doesn't work or when you have to rank order, when you have to order things in maybe ascending order or descending order, Pearson doesn't really work well. It works, but not as precisely. You need Kendall's and what's the other one? And Spearman's, okay? All right, for number 6. So for number 5, the answer is what? C? Pearson, yeah. For number 6, suppose you wish to evaluate whether the order, So the key word here is order. So your rank ordering. So which of the 3 do we use best for ranking and ordering? It's definitely
Ranking and ordering was the Spearman and Kendall, but
Spearman,
not Pearson.
exactly. It's Spearman and Kendall, but not Pearson. So you have to look for that choice because you already know it ahead of time. So what choice is that? It's Kendall? No. It's Spearman and Kendall. So it's B, right?
B.
Okay, B. Okay. Again, if you have questions or you want more explanation, when I see you one-on-one, then I can discuss more with you one-on-one. Okay, I can explain more about why it is and go over what we did in class. Number 7, the portmanteau tests of Box, Peirce, and Leon Box are used to test for which of the following? Number 7. Which of the following? Number 1, we use it to test whether jointly even before looking at the answers, I can think about it. We use both portmanteau tests to test jointly whether the autocorrelations are 0, not each one individually. Remember the homework? We do jointly. So it should be whether the autocorrelations are so it is D, right? So D is the correct answer for this.
Yes.
Whether the autocorrelations are individually and jointly equal to 0. So individually meaning the autocorrelation in lag 1 equal to 0, equal to autocorrelation in lag 2 equal to 0, equal to autocorrelation in. So individually we are saying they are each 0, also jointly. Okay, so that's what we use the portmanteau test to test.
Professor,
Yes.
I could have swore that the portmanteau was mainly just jointly and the T test was individual.
Yes, so for individual, I can test only for lag 1.
Yeah,
Only
so
for
why
lag 2.
would B be the answer?
Why would?
Because it says individually and
Which you mean for number D?
7, yeah, letter D.
So D says, okay, if you see how we write the equation, it says not only are they individually, but also jointly together. Okay, remember how we write it is row 1 equal to row 2 equal to row 3 all of them equal to 0. And I did remember in class that I said when you test it, you test for row 1 equal to 0, equal to row 2 equal to 0, equal to row 3, where the row meaning the autocorrelations. Okay, so individually and jointly is what we are testing. And remember, what is the alternative to this test? Does anybody want to tell me what the alternative is to this test? That at least one of them is not 0. You see that? If only one of them is not 0, then we reject this null. So the null means they are individually 0, but they are also jointly 0. The t-test, Daniel, we test for only that individuals are 0, only. Okay?
Is it the Jack-Barra test?
No, not the Jacques-Barra test is a test for normality. It is the t-test. Remember you guys did this for homework too.
Professor?
Yes, sir.
Just the book, if we go to page 47, it says we are testing jointly that several autocorrelations of XT are 0. It doesn't say individually.
Yes, but what is the alternative for that test?
The alternative is there's at least 1 0.
So
when you're testing it jointly, though.
Yes, but the way you write it is row 1 equal to row 2 equal to row 3 equal to row 4, and all of equal to 0.
Yeah.
So if row So if row 1 is 0, then that null doesn't hold. I'm sorry, if row 1 is not 0, then that null doesn't hold. Okay, so in words, this is how you state it individually. And you remember the key word is and. I didn't say or. If you use the word or, then t-tests are what you do. Okay. All right. So I mean, we can discuss this at individual session, but this is the way you say it in English. If you write the equation, then remember the equation is row 1 equal to row 2 equal to row 3 equal to row and equal to 0. Essentially, what you're saying is row 1 equal to 0 equal to row 2 equal to 0 equal to row 3 equal to 0 Okay. Let's talk more during the individual sessions. All right, number 8. But this is how you state it in English. Now, how about number 8? This is another portmanteau test question, number 8. What are we testing with the portmanteau test? Wait, is Alec in this class? He's quiet. Is Roxolana in this class?
I am here. I am here.
Is Roxolana in this class? No. All right. All right, Alec, you're here. That's good. I saw you, but I'm just kind of messing with you. All right, so anybody give me the answer to number 8? Number 8 is E. Serial correlation. Isn't that what the autocorrelations are?
Yes.
It's serial correlation. So E is the answer. Most of you got this correctly. So how did you get it? I checked. Many of you got that correctly. So maybe you're not sure right now. But that's what we're testing with box pairs and Leon box. So that's another way of stating this thing for number 7, okay? So we're testing if the correlations are 0 jointly and individually. All right. Number 9, of the two main parametric measures of dependence, Kendall's and Spearman's, which one is generally lower in size? Which of those two is generally lower in size when you calculate them? We discussed this in class. It's in the
Kendall.
Exactly. It's Kendall. It's in the handout I posted. I mentioned it. Many of you mentioned it to me. Many of you in the homework too, you flagged it immediately. You told me that the difference is that Kendall's is always smaller than Spearman. So this one was a giveaway. Number nine, somebody was asking me about
Normal?
About Jacques Berra. Number 9, why do you say it's not normal?
Because the test shows that the test is asking if it's normal. The
Okay.
alternative test would be that it's not normal.
Okay, so
it
why
could be
did
any of those options.
Wait, who is talking?
Andrew.
Andrew, so why are you choosing the alternative that is not normal?
Because it was the p-value is close to 0.
How do you know?
Because of the number.
How do you know about the number? I'm just messing with you, but I want
because
you to
I've used the calculator before.
Exactly, because this is e to the negative 12, right? Right, Andrew?
Yeah.
Okay. So this is, thank you, Andrew. I'm just kind of pushing you to give me all the answers, because this is like 8.09 divided by 10 to the 12th power. I mean, if this is as close to 0 as it gets, right? Thank you, Andrew. So because this is much less than 0.05, right, at the 95% confidence, then that means you reject the null. But you have to know what is the null hypothesis for the Jacques Berra test. Does anybody remember what is the null hypothesis?
Yeah, that the distribution is normal.
That the distribution is normal. And because now we are rejecting that, we're rejecting it in favor of alternative, which is not normal. So the answer should be what? B,
B.
right? Okay. So for many of these tests, it would be nice if you just keep remembering what the null hypothesis is and what the alternative is. For the number 11, I think number 11 is a little tricky in the sense that you need to slow down and read the question. That's the only trick there. But what do I require you to do here? You have to compare the t values to the critical t.
I think it was lag 3. I think that's what I put.
It's exactly like 3. Because look, the critical T is negative 1.96 to positive 1.96. But for lag 3, this is negative 2.24. So it is way to the left of the critical region, yes? So if it's way, it is outside the critical, exactly, it is outside the 1.96 boundary. Thank you, Andrew. That's a more formal way to say it. Thank you. So because it is outside, we reject the null, and therefore for lag 3, it is significantly different from 0. Because, Danny, this is the t-test for the individual, right, Danny? This is the t-test for individual. So you have to consider each individual one. And number 3, it falls outside of this region, so we reject the null. So it's lag 3. All right. Number 12, the most fundamental time series model is, what is the answer to number 12, anybody?
C.
I put white noise, but I don't know.
It is white noise, that's correct. What do you mean, William? Of course you know. Because before I started to derive the auto-regression models, and then next week I'll deal with the moving average. I said the starting point for all this time series is the white noise process. And then other time series models are kind of combinations of the white noise.
I put white noise because I was thinking about the formula, and I was thinking about the error term. And I was like,
Yes.
oh, that's pretty
You're correct.
fundamental.
You're correct, yes. So it's white noise. So this was one of the easy ones. How about number 13? The Wall Street analysts collect financial asset prices and notices that the seemingly random variation do share some common. So it's B, right? That's the definition of stylized facts. Right?
Yep.
Okay. So B, so number 13, the answer is B, because that's the straight definition of stylized facts. There are properties that are common. I think in class I use the example, if I come from Mars and I say, what is, common among Americans, what is common among Chinese, what is common among Nigerians, what is common among, so we're looking for commonalities. All right, so those are things. How about number 14? Which of the following is not, which of the following is not?
I was between cycle and cyclical.
That was a little confusing.
Yeah, this one's a trick question in my opinion. It's like either one is like, it's like 50-50.
Exactly. So
Kind of messed up.
I know. Thank you. Professors are messed up. So which one is it? Which one is it?
C.
Third one.
It's C. Yes, it's C. Okay. I'm sorry about that, but here you needed to be sure of the difference between cycle and cyclical. Okay. So cycles are things. Remember the definition. Trends are long-term upward or downward. Cycle, like business cycle, every 5 to 10 years. Cyclical, it's like circle. This doesn't make sense here. So A, B, D, and E are components of the time series. C is definitely not. Number 15, which of the 4 moments of a distribution tells us about the shape? You excellent students in this class, a couple of you got this wrong. I think we already discussed that. If you have any doubt, just think about the skewness. It can be shaped to the left, it can shape to the right. So that is that's about the shape. So it's skewness. Kurtosis is fat tail, right? Remember, kurtosis is a fat tail thing. So the answer to 15 is what? D, third moment. That's what I intended, right? And many of you got that correct, but just a couple of you didn't get it correct. I meant that to be a giveaway. Number 16 is not such a giveaway. Because number 16, most of you will be thinking the second moment. That's why I forced you. I didn't give you only one moment as the answer. That was deliberate. That was a message for me to tell you that there are 2 of them. So think about the 2. So the answer is what for number 16?
I personally put second and third.
No, it's second and fourth. Remember in class, I had said in class that the odd number moments tell us about central tendency and shape. That's 1 and 3. The second and fourth give us idea about riskiness. So it is second and fourth. This is a little tricky. Okay, I can tell you. But that's why I didn't give you only the second. If I gave only the second, then all of you that took the second, I'll give you full points. Okay, so I said I won't give one choice. I won't give the second or the first, the single as the choice. I gave it 2. So I needed you to think a little bit about it. I did say it in class, but of course, sometimes, sometimes it's quick or sometimes you forget. But if you think about it, what is kurtosis? Kurtosis is the probability that returns far removed from the mean, either way, oh my God, either way up to the top or way down below to the loss column. The probability that that returns very far removed from average will occur. That's what we call fat tail. If the probability is larger, that an extremely large or extremely low return removed from the mean is more probable than the normal distribution, then that is riskier than the normal distribution. Okay, so it's the second and fourth. All right, number 17. Agnes, an analyst with JP Morgan, wishes to test if the annual returns of the Dow come from a normal distribution. Again, which pair of moments of the distribution would be the most relevant? What do you think? Which 2 moments do we use to test for normal distribution? Whether your
Third and fourth.
Third and fourth, exactly. So that's number A, right? It's A question. It's A answer, right? Okay. Number 18, Shao Yu is my good friend. He was a PhD student at Baruch College. His name is Ross. He just finished last year and now he's back in Guangzhou in China. So I'll be visiting with him as soon as the pandemic is over. So Shao Yu was a PhD student at Baruch College, and he got his PhD in finance last year. He's a star analyst, blah, 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 blah. So what is the answer to that? He collects and plots the time series. Sorry, let me read this. This is a star analyst with Shanghai Securities Company. He collects and plots the time series of weekly returns of Shougang Beijing Steel. Shougang is one of the biggest steel companies in China. I have done a little consulting work with them. Actually, not just me. They came to Baruch College and some of us met with them, some professors. So he collects this over a weekly period and he notices a persistent upward trend in returns. Guys, this is a little tricky. Remember for your homework, Danny and William and Alec and Lily and so on, when you plot prices for your homework, what happens, right? You notice a trend, correct?
Yeah.
But when you calculate returns and you plot, do you notice a trend?
Well, only that it stays by the mean.
It stays by the mean of 0. So so calculating returns is a way we use to detrend a series. We remove the trend by calculating differences or calculating returns. And all of you in this class, whenever you have plotted returns, it just varies up and down around the mean of 0, no trend. So when there is a trend, what does that mean? It means it's not stationary.
Yeah, Professor, I was thinking that so when I asked you about the graph, like if we could show some graphs, I was referring to this question because I was having trouble visualizing it.
Okay. Okay. So, but again, that's okay. That's fine. But just from your homework, if you thought that when you change things from prices to return, you never notice a trend. So when you notice a trend, that gives you the idea that it is not stationary. Because what is stationarity? Stationarity means that the average, remember one of the conditions is that the mean is constant. So when you calculate returns from prices and you plot it, you notice that the graph just keep going up and down around a constant mean of 0. That's a definition of stationarity. So this is one of those application questions I like to ask, okay? So B is the answer to number 18. Number 19, you plot the graph of the time series of returns of Microsoft over the last 25-year period. You notice that there are volatility clusters. Okay, so what do we mean by volatility clusters? Essentially, I wanted you to define for me what is volatility clusters. Yes, Andrew, you're correct. Sorry, I don't know why I'm sharing this. Sorry, something just went wrong with my computer here. What? No? Please hold on, I'm just having a moment here. God damn it, what am I doing? All right, give me a second, okay? Something just went wrong here. I cannot blame it on the flu shot, on the COVID-19 shot. Please give me a second, guys, please. I am trying to bring it back up. Sorry, guys, I think I just lost my position in here. Let's see, let me bring it up again. Cancel, okay. Sorry, I think I accidentally hit the save button. So, all right, sorry about that. I accidentally hit a button here. So number 19, what is volatility cluster? Andrew, I think you gave me an answer. What was it again? Wait, let me. Yes, C is the correct answer. So volatility cluster is, remember when you guys plot returns, when you plot a graph and you see low squiggles followed by low squiggles, and then very large squiggles followed by very large squiggles, that is volatility clustering. That is what we model with Arch and Garch in chapter 4. So volatility, sometimes it's a trick question. We say, is it period of low, is it low followed by high and high followed by low? No. Volatility cluster is low volatility periods clustered together and high volatility periods clustered together. They occur together. So that's C, okay? Number 20, which one of the stylized facts has the following property? Danny, you want to give me this answer? Which one of the stylized facts has the following property? One observes large drawdowns in stock prices and stock index values, but not equally large upward. Wait, hold on. Before you give me the answer, who's giving me the answer on chat here? Andrew, I think. Okay, so let me show you the. Let me show you the handout. This one. What does number 3 say? One observes large drawdowns in stock prices and stock index values, but not equally large upward movement. I think I mentioned this in class sometimes that, that sometimes when you look at when you look again, did we see this in class in one of the, I don't remember the occasion, but sometimes when I think let me give you an example, okay? I think an example will best do this. When if you look at crude oil prices, okay, sometimes you hear in the news that globally that crude oil prices have gone up. Yes, that crude oil prices have gone up. And then what happens at the pump when you go to buy your gasoline for your car? When crude oil prices in the world has gone up because of maybe some political problem somewhere around the world, right? You notice that if crude oil prices in the world, crude oil, we use it to make gasoline for cars and aviation. When crude oil prices in the world have gone up, it shows up on the pump. For example, if they go up by $5 in the world, maybe it shows up by, let me use a simpler example. Suppose crude oil prices in the world goes up by $1. If you go to the pump to put gasoline in your car, gasoline prices, remember gasoline is obtained by refining crude oil prices. Gasoline prices will go up by $1 a gallon. I'm just using an example. So 1 to 1. And then 1 month from now, you hear in the news that crude oil prices in the world have gone down by $1. The question is, if you go to the pump, will the gasoline prices go down by the $1? Typically, no. Okay, typically no. So that's an example of a crude gain loss. It will decrease by less, yes, of course. So that's an idea, just a quick example that comes to my mind about something like gain loss asymmetry. And we notice that financial asset prices behave like that. Okay, that price increases and price decreases, they are not symmetrical in that sense. All right. So it's E, gain loss asymmetry. So how about 21? Anybody give me the answer for 21? This is for the portmanteau test, but this is for the long box test. Here, you look at the p-value, right? What does the p-value tell you? Do you accept the null or you reject the null? Anybody?
Fail to reject.
So you fail to reject, exactly. I use accept, but please don't tell my finance professor friends. So you fail to reject. So what is the answer here if you fail to reject? Because even if you know that you do not reject the null, one of these options can throw you off when we state them in English, in words. So which one do you think is the best answer? Is it auto? Huh?
D?
Is D, yes. So autocorrelations up to lag tested are statistically significantly and jointly not different from 0. So D is the answer. This can be a little confusing. So my suggestion is when you write the null and when you're studying the null and the alternative, you can write it in symbols, but you should also think about them in words, okay? Because sometimes it's a little confusing when you think of them in words and you can become not quite sure. Okay. Number 22, which of the following statements is true? Anyone tell me this? I think I designed this to be quick and easy for you. Which one of the choices do you think number 22 is?
Is it A?
It's A, yes. Because in this class, remember when I introduced stationarity, I said there were a number of concepts of stationarity, weak stationarity, strong stationarity. I think, Danny, it was you that also mentioned, I don't remember if it was you or Alec or Andrew that mentioned ergodicity. I also mentioned that. I said, no, we're not going to be thinking about all of those. We're only going to be focused on weak stationarity in this class. And we have continued with that. All right. So it's A. Number 23. This is a little tricky, but many of you got this correctly. In fact, most of you in this class. What was I planning? What did I need you to do for number 23?
I put C because I thought it had to be between -1 and 1. And that was the only option. I don't know if that was the right answer.
Okay, that's the right answer. C is the right answer, but for a slightly that's a way of thinking about it, correct? But if I had said C would be the answer in this way. Who gave me this answer? Was it William or Alec or Andrew?
It was Tobias.
I'm sorry, Tobias. Sorry, Tobias. So the answer is C. I remember. Sorry. Yes. Oh my God.
Not that elite.
He deserves extra credit now.
Yeah. Okay. So yeah, Tobias. One second, Tobias. That would be exactly the answer if I also gave you the assumption that this series x of t is stationary. Okay, I didn't give it to you here because I wanted you to think more broadly. But you're correct, because the AR one I gave you here is actually stationary, even if I didn't mention it. But what I wanted you to use was the fact that the AR series, you can determine the autocorrelation by taking the lag, by taking the 0.7 to the lag number. So it's 0.7 raised to the power 4. Okay, go ahead and calculate it now and tell me what answer you get. 0.7 times 0.7 times 0.7 times 0.7 because it's lag of 4. So 0.7 to the power of 4 should be 0.2401. Yes, something like that?
Yes, Professor. That's how I got it.
Yes, that's the way I wanted you to get it. Okay. But Tobias, your answer is correct. But the assumption has to be that series xt is stationary. Okay. And for an AR1, for an autoregressive model, especially this AR1 model to be stationary, the coefficient must be, the absolute value of the coefficient must be less than 1. So that's correct. That's another way of thinking about it, okay? But what who gave me that answer? Was it, who, Nadia? Who gave me that answer? Okay.
What for the lag?
Yes.
I did.
Who? Who?
Natalie.
Oh, Natalie, sorry. Natalie, that's correct.
Not me.
Okay. Natalie, that's you. Thank you. That's correct. I can't see the whole screen right now because I'm sharing this. Sorry about that. But that's that's exactly the answer, the way I wanted you to obtain that answer. Okay. So it's 0.7 to the power raised to the power of 4 to the exponent 4. 0.7 times 0.7 times 0.7 times 0.7, because I'm asking you for the autocorrelation at lag 4. Remember during my proof in class, my handwritten proof, I proved the properties of an AR1 model, and this is on the last page, page 7 of my handwritten proof. You have it on Blackboard. So, and I discussed it the week before the exam. Number 24, which of the following is not a characteristic of a weakly stationary time series? This one is just a little tricky, but we have discussed all these properties before. A weakly stationary time series, the mean is constant, is invariant. The variance is finite and invariant. The lag k, the autocovariance depends only on the number of lags time series. Sorry, ouch. On the number of lags separating successive observations. We discussed it in class, that if it's a stationary time series, then all observations separated by 1 lag will have the same autocovariance and therefore the same autocorrelation. It doesn't matter where in the series you started. We did this in class. But if they are separated by 3 lags of time, then all observations separated by 3 lags will have the same autocovariance and autocorrelation. It doesn't matter where in the series you start. But the autocorrelation for autocovariance and correlation for lag 3 will be different, can be different from the autocovariance and correlation for lag 1. As long as all lag 1s are the same, all lag 3s are the same, all like 7s are the same, then that satisfies it. So A satisfies it, B satisfies it, C satisfies is good. D is good because stationarity means the mean is constant, the variance is constant. Weak stationarity, the mean is constant. That means it's always coming back to the mean. If interest rates are higher than the long-term average, they will eventually come down. If interest rates are lower than the historic average, they will eventually go up. I think I used the interest rates as an example in the class. So the answer is E. E is the one. E doesn't make sense, actually. Log returns and simple returns, there's nothing that tells us whether they'll be normal or not. Whether we are using log returns, when you download prices, whether you convert them to log returns or whether you convert them to simple returns, you still have to use Jagbera to test whether they are normal. So there's nothing that tells us before the fact that it doesn't matter whether you used log and normal. Nothing tells us that they should be jointly normal or separately normal. Nothing. Okay, I hope that's clear. Number 25, a commonly observed feature of an AR model with positive coefficient on the lag variable is what? Does anybody know for number 25? I think we discuss it every class.
B.
Yes, it's an exponentially declining autocorrelation function. Yes, thank you, Nadia. We discussed this even 2 days ago. I talked about it. Okay. I'm out of breath. All right. Any questions? Okay, so thank you. Thank you, Ian. How many of you tried the command, the program I gave 2 days ago? William, you tried it, right? Or you have a question?
Yeah, I tried it.
Okay, so
No
give me your comments. How did it go? Did you step by step, were you able to follow it and get the results?
Yeah, it was pretty clear. I think your demonstration on Tuesday was good.
Okay, thank you. So for your homework, and please, I would try very much to post homework tomorrow, okay? Before midnight tomorrow. Please, if you don't find the homework before midnight tomorrow, do not fret. It means maybe I'm knocked off. I don't anticipate that. Then on Saturday, I'll do that. I'll post it. But whenever I post it, I'll give you 1 week to do it. But let me tell you, William, if you can do it on the Saturday, knock it out on Saturday, okay?
Mm-hmm.
Because the homework will follow exactly what we did in class. I will just ask you, for the stock that you have been using for homework so far. If you want to, you can get another stock. But why do you need to do that? Just use the same stock that you have been doing because you already calculated the returns. I'm going to ask you.
Do you also want us to work in groups or?
No. This one is not the groups. This is individual homework, okay?
Okay. Mm-hmm.
So here, William, to practice what you practice, you used the GDP data I gave you, right? You use the same one.
Yeah, the one you uploaded on Blackboard.
Exactly. For the homework, you will not use that. You will simply use your own stock.
Mm-hmm.
Okay. Use the return. Do the AIC like you did, and I'm going to ask you what is the null hypothesis. If you say choose this because I ask you why, you say because AIC is minimum. Okay, that is if it's really minimum.
Oh, okay.
If I ask you to do the ADF test and you say the ADF tells me it's not unit root or it's unit root, I'm going to ask you why. You're going to say because the p-value. So the only difference between what I did in class and what you'll be doing for homework is that you will be using your own stock, okay? That's the only difference. So please knock it out quickly. This is not something you do over 1 week. I really would appreciate if you finish it on time, you submit before the due date, I can grade it ahead of time so that I really don't have to wait to grade the whole class because Usually, I don't like the TA to grade it because, you know, I like to grade it myself. So I know where many of you have issues so I can discuss it. But so if you can finish it ahead of time, do it, review it, and so on and so forth, and then submit it. I'll just grade it for you, okay? And give it back to you so that I don't have to wait to the end, because I want us to, I want us to do one more homework on GARCH, okay? Again, because the textbook comments for GARCH, I'm not really very hot on them. Okay, so what I will do is when I introduce GARCH for you, I will run the commands in class just as I did 2 days ago, and then I'll give you homework for you to use your own stock and repeat. I don't, please, unless you want to be fancy, but I don't require that to happen. Use exactly the commands I give you in class. After using that, then you can be fancy. You can try other things. So I want to be able to give you one more homework after this one, after tomorrow's one, on GARCH, so that at least you've practiced GARCH before the end of this class, okay? All right. So the homework I'm going to give you tomorrow, it's easy. I'm just going to give you 1 week to submit it because that's normal. But you can, if you have practiced the comments I gave you last Tuesday, then this shouldn't take you more than 2 hours to do the homework, if at all. Okay? All right. Any other questions? Somebody else did it? Anybody else tried it? Speak up. I'm sure you tried it, even if you didn't make a mistake. All right. For homework, what I'm hoping to do for the exercise I did in class on Tuesday, if you notice towards the end, I did ARIMA 100, ARIMA 101, ARIMA 201, and so on. But for the homework, since I haven't introduced you to moving average, for the homework, I'm just going to have you try a few AR models. I'm going to say, try maybe AR1, AR2, up to AR5, and see which one fits best into your fits best with your stock. So I'm going to say try ARIMA 100, ARIMA 200, ARIMA 300, 400, 500, because the second and the third letters are 0. That means it's not a moving average. I haven't formally introduced you to a moving average. So I'm not going to ask that for homework this time, okay? So if I ask you to try all those 5 and you try them and you choose the one with the minimum AIC, if you want to, if you're still not satisfied, you can then try other models, okay? And tell me, Professor, I tried other models. This one seems to be better than the one you restricted us to try. So you can be adventurous in that sense. But I think I'm going to restrict you to either AR1 to 4 or AR1 to 5, okay? All right. Any questions? All right, one more thing I want to explain, okay? Again, I'll talk about this again and again and again and again. But last class, I think I just because time was running out, I didn't focus quite on it. You remember when we did the portmanteau test? I introduced 2 portmanteau tests, the box pairs and the Leung box. And I said one of them was more restrictive than the other. The box pairs was much more restrictive than the other one, than the Leung box. So generally, we tend to use the Leung box test because it is less restrictive. The same thing when we test for unit roots. Okay, I have discussed that, and I showed in the practice example last Tuesday that we can do unit root by Dickey-Fuller test, the DF, or we can do unit root test with the ADF, the augmented Dickey-Fuller test. Now the question is, what is the difference between the augmented and the non-augmented, the straight DF and the DF? Okay. So the difference is this: the ADF is less restrictive. The DF is more restrictive. I think that's where I stopped last class. And then after class, I said, okay, next time I will explain more. Because from now to the end of the semester, we're going to still be using the AIC. Because when we do GARCH, we might run if different GARCH models, and we're going to ask which one is the most appropriate for us to use to model volatility of the errors. So we might look at 3, 4, 5 different models, and we say, okay, number 3 is the best because its AIC is minimum, okay? So that's one. And sometimes we might also want to test for unit root tests, okay, as we go on. So what I'm going to say now, I'll say it again throughout the semester. When you do particularly unit root tests and you use DF and ADF, DF is much more restrictive in that it allows you to, if we are testing unit root on AR1 model, in other words, we are trying to see whether the coefficient is 1. Remember on the midterm exam, we just saw a few minutes ago where the coefficient was 0.7. But if we want to test whether it's really a unit root test, we are testing to see statistically if it's not 0.7, but 1.0. Unity, 1, okay? If we want to test it on that particular AR model, then to use DF, you have to assume that your error term in that equation is white noise. For whatever other model you want to use DF to test. You must assume DF test works best when you assume that the error term in that model is white noise. If the error term is not white noise, then Dickey-Fuller, the DF test cannot be relied on. The T statistics, the P values, you cannot rely on them. That's why we go and use the ADF. The augmented DF test allows you, it doesn't restrict you to the error term being white noise. It allows the error term to be anything. It can be AR, it can be MA, it can be ARIMA. So how do I say? It gives you freedom to use that test for situations where the error is not white noise. But DF is very restrictive. It has to be white noise. So that's why in research, most people, they report the ADF rather than the DF, unless you are particularly sure that your error terms are white noise, okay? Sometimes they are, sometimes they are not. But because many researchers don't want to just spend time doing it, they say, okay, we're going to use the ADF. At least I can rely on the ADF, even if the error terms are not white noise. That's why the ADF is much more popular than the DF, okay? I didn't say this on Tuesday, but after the class, I just said they may not understand what I mean by restrictive. So the DF is much more restrictive. It requires you to test that your error term in whatever model you're using, it allows you to test that the error term is white noise. And if the error term is not white noise, then you must use the ADF. It's better, okay? I hope this makes sense, but again, if it doesn't make sense to you, that's okay. I'll keep mentioning it in class. You can always say it's the DF is more restrictive. But if I ask you to, why is it more restrictive? It's because the error terms have to be white noise. Okay. If you didn't practice with the comment I posted on Blackboard on Tuesday evening, please at least try and practice them between now and tomorrow, or between now and when I upload the homework, okay? Because that's exactly what you're going to be doing. The only difference is towards the end, I'll ask you to check your stock returns to see whether they fit into best, whether AR1 or AR2 or AR3 and so on will best model your time series of returns of the stock, okay? And what I intend for you to do is to do the AC, to look at the AIC, just like we did in class, and choose the one that is minimum. Okay. All right. Okay. Sorry, guys. I think